Hi, we are going to discuss today about bus structures. So last session we have seen the historical perspective of computers. So this section we dive into the next topic. It is called bus structures. Mainly these bus structures are used to communicate or take the data carry from one component to another components. We are going to discuss in detail about how the different buses were available. Normally we have three categories of buses: address bus, data bus and the control bus. So address buses are used to communicate only the address lines from the processor to the other components, and data bus is available. Data bus is used to carry data to and fro from the processor to memory devices. And there is one more special bus is available. It is called the control bus. The control bus will carry control signals from the processor to other devices, or from the control unit available in the processor environment to other devices, in order to control the operation of the devices, or in order to check the status of the devices, whether the devices are in the working condition or the devices are in the off conditions. Okay, so let's see few theory about the bus structures. So one of the basic feature of computers is ability to transfer data from the main processing environment to other devices. Other devices in the sense it may be from IO devices or it may be from the memory devices. How the data will be effectively transferred from the central processing unit or the processor to other components of the computer system. That's what mainly we need a media through which this data transfer will happen. So this communication capability enables a human operator, for example, to use the keyboard and the display screen to the process text and the graphics. So these communication lines will enable the user to communicate with the system, so that the user programs or user data will be communicated to the CPU through in the form of communication lines. Then the processed output will be once again sent back to the processed environment within the CPU to the graphical output devices, so that the user can able to understand the outcome of the processed output or the input given by the users. He can able to see the processed output in the form of monitors or in the form of printers also. So the data will be effectively transferred from the standard input devices to the CPU and to the memory, from the memory to the CPU, and from the CPU to other external devices like display devices or other devices. So we make extensive use of computers to communicate with other computers over the internet and access information around the globe also. If I want to transfer data to other computers, the other computers in somewhere in the globe, then it is also possible. There is a special communication lines required to carry or to transfer data from the local computer to another computer which are connected through the internet. A computer should have the ability to exchange information with a wide variety of devices. It should support the format of the different categories of devices also, because if you are accepting data from the input data format is different. If you send data to the output devices are different, maybe graphical devices, maybe printer or other form of devices. So it depends upon the output devices. We need to format the data. Also, however, the data transfer may also take place directly between IO devices such as magnetic hard disk and the main memory, with only minimum involvement of the processor. This concept is called direct memory access, in which the data can be directly transferred from the hard disk to memory. Whenever we want to execute the large volume of data, what is the problem with the processor? Each and every time the processor will control the transfer, it will make the execution very slow. So during that time, with the help of the processor, with minimum involvement of the processor, the data will be directly transferred from the hard disk devices where the huge volume of data is available. If you want to execute that program or instruction, that should be brought back to the memory. So that direct data transfer between the memory and hard disk, we can call it as direct memory access. The direct memory access is a very important concept in use. Later we are going to study in detail about the direct memory access with the help of DMA controller or POP process. There is a special processor. Then we can see later in the 4th unit, as well as this possibility will be explored in the next chapter in the memory system, 4th chapter. Yeah. So the interconnection network is used to transfer data. Yeah, it is. This is actually the bus structure. So how a processor and memory and all the remaining devices, they connected with some common buses. There are different varieties of bus. For simple understanding, we have this common line. So the input devices are output devices. That's what we generally call it as IO devices. We have n number of IO devices. These IO devices want to communicate with the system. It is not directly possible because of the speed mismatch of these processors, because the processor working speed is it's millions of instructions per second, but IO devices are too slow. Because of this limitation, these devices will not be connected directly to the processor and directly to the memory. So they have a common bus system. It is called a shared bus or common bus. So they deposit or they place the data onto the common bus, so that whenever there is a requirement, the processor will take the data from the common bus and it will process. The processed result also once again placed onto the common bus. Then the data, the memory also will working based on the same concept. So the data transferred from the memory will be taken from the common bus, and both reading and writing cycles. Reading cycle means taking the data from the common bus to memory. Writing means taking the data from the common bus and we are placing it to the memory. Reading means the content available from the memory is placed onto the data bus, so that the data will be moved in and around the processors and IO devices. So this is still a detailed diagram of the different address lines available or different data buses available. This is called IO interface for an input device. Normally the input devices will not be directly connected to the processor, as I told you earlier, because of the slow nature of the data transfer. They are very slow actually. It is called indirect data transfer. So because of the slow nature of input devices, the input device will not be directly connected to the data buses. Instead, they have a common interface. It is called IO interface. Each device, they have a separate interface. The interface contain data, status and control registers. These registers are used to indicate to the processor whether the data is ready, and the second register is called a status register. The status register is used to check the status of the input device, and the control registers are used to control the operations, which operation we are going to perform with the input devices. Especially the reading operation is enabled. Reading is the only operation enabled on this one, so that the processor through control register, it will monitor it will control the input device. It will monitor the status of the input device through the status register. Data will be placed onto the data register. So the CPU will read the data from the data registers. Also there is a control registers to control circuit is to control, that means additional circuit that is required for controlling the input devices. And there is an address decoder is available in order to decode the address, which address we have taken actually. So as I told you earlier, we have address lines, data lines and control lines. So address lines are used to identify which address the data is stored actually. For which address we are going to place this data, so that the data will be placed onto the address will be taken from the address lines. So that address decoder will act as a decode the address, that means through which the data will be moved to. And the second one is in a data lines. So the data will be transferred. Actually it is a single line actually, because it is an input device. The input device can able to place the data that is available on the data register. From the data register, the data will be placed onto the data bus or data lines or data bus. So the control lines will be taken from the control line and it is available in the control registers. So this interface, we will see the detailed working of the interface in the 4th unit itself. So what is the purpose of this interface? On behalf of the input device, this interface will communicate with the processor. That is also not direct communication. The data will be communicated through these address lines, data lines and control lines. So address lines are used for carrying the address. Data lines, it is a dual lines, so that data will be transferred from both processor to interface and interface to processor. And the control lines only, onward control lines only. That means the control will comes from the processor only. Okay, so these are all the simple concept of data interface. The device that recognize this address responds to the commands issued on the control lines. The processor uses the control lines to request either read or write operation. In case of input device, reading is possible, only reading is possible. In case of output device, only writing is possible. Some devices will do both, like hard disk like kind of devices. Both reading and writing, both read and write operation is possible, and the requested data are transferred over the data lines. So the devices are controlled by the control lines. If the processor want to know whether the device is ready to accept or the device is not ready to accept, then there is a separate line is used for, that is called a status line. Okay, so all these are communicated through these interfaces, various bus structures available. Next class, next session we are going to see about the different data types available. Okay, thank you.